Right, ladies and gentlemen, one last video for today. We are going to look at a initial condition problem that is a little bit more difficult than the first one that I showed you. Not necessarily because of the differential equation itself, but because we have, maybe something with a numerator and denominator rather than just a conventional power rule. So let's kind of stay true to that multi-step checklist that we have. So we want to ask ourselves, is the variable separated? And then take the antiderivatives on both sides. So once when we do that, then we can kind of think about our initial condition and plug it in, solve for C, and then we will, get that Y equals 2 by itself. Solve for Y as needed in this case. So we are going to have to do a lot more solving for Y after we kind of incorporate those initial conditions. So I want to just convert, like on the last one, our initial condition. So I like to kind of think about this as our X value that we want to be able to put in is 0, and our Y value that we want this equation that we're solving for to run through, we want that Y value to be 2. So we want it to go through, 0, 2. Our first goal is to get the separation of variables. So we have, a lot going on. We have X's and Y's on both sides. Now, it does look like that if we do cross multiply, we can get that separation of variables. So this is a prime candidate for cross multiply. Now, if we have 1 over, X stuff, like on that homework example that I showed you in the first video, then we could kind of do negative exponents. But now we really do have to cross multiply just because of the mixture of the X and Y's and the lack of separation on both sides. So we're just going to go ahead and do that right now. So I got 2Y equals 2. And we'll write this as 2y dy. And I have x squared plus 2x dx. Now, to show me that you know your stuff with differential equations, you should be able to recognize that once when you have gotten that variable separation that you are integrating on both sides. So I'm going to get, on this side, a y squared. And then on this side, I get a 1/3 x cubed, because 3 times a third is 1. And then I'm going to get a 1/2 x squared. And we have a plus c. Now, I have enough information with my initial condition now to plug in my x and y and solve for what that plus c is. So I'm going to say that 2 squared is equal to 1/3 times, and I love having 0 here because this stuff is just going to go away. And it turns out that our c is equal to 4. Now, here's the bad news. We have y squared, but we need y. So we have to solve for y. So when I do that, I'm going to get that y is equal to plus or minus the square root of 1/3 x cubed plus 1/2 x squared. And I know what my plus c is, so I'm just going to put in a 4. And because y is by itself now, we have completely solved the differential equation. So let's look at kind of the easy versus hard example side by side. So our easier ones, they're already going to be very close to having that separation of variable. If they're not, it's just kind of a polynomial, no fraction, straight shot, with a power rule, antiderivative on both sides. And what's also nice about number 1 is that y is already solved for after you integrate. Number 2, the differences with that and what makes it maybe a level up is that you have to be a little bit more intentional about those separation of variables and recognize the need to cross multiply. And when you do integrate on both sides, you get y squared but not y. But after you find your plus c, then you can kind of go back and solve for that y and incorporate for your plus c that 4. So we'll have a little bit more differential equation practice today, and then also have you try out an example where you are using an initial condition to come up with a particular differential equation. Best of luck today. Bye-bye.